What causes intermodulation in an electronic circuit? A. Too little gain. B. Lack of neutralization. C. Nonlinear circuits or devices. Or D. Positive feedback. The answer is C. Nonlinear circuits or devices. Our next subject is radio modes and equipment. Let's take a look at digital protocols and modes. Here is the format of a radio teletype signal. The mark and space tones are two separate tone frequencies. Radio teletype, or RIDI as it's called, has a very distinctive sound as the signal switches back and forth between two tones. These two tones can then be converted into binary ones and zeros. Here is an example of frequency shift keying known as FSK. The binary ones and zeros are used to switch the modulated signal back and forth between two tone frequencies. Here is an example of my favorite digital mode, phase shift modulation. As you can see, the phase of the signal reverses to signal a binary zero. It is important to know that the faster you send a digital signal, the more bandwidth will be required. For instance, PSK31 only requires about 31 Hz of bandwidth, and as a result, most people can type faster than the signal can be sent. PSK64 requires twice as much bandwidth, but will support twice the data rate. Protocols are the rules for how signals are encoded and decoded. Codes are the method for converting information to a digital form. For instance, Morse code is a type of code. That code of dots and dashes may be sent in any one of several different protocols. What is the bandwidth of a 170 Hz shift 300 baud ASCII signal? The equation is that the bandwidth equals K times the shift quantity plus B, where K is the keying constant, 1.2 for radio teletype. The shift is the shift in Hertz, in this case 170, and B is the symbol rate in baud, which is given as 300. So we have a bandwidth that equals the quantity 1.2 times 170, quantity plus 300, which equals 504 Hertz. One form of digital mode is known as Pacor. Pacor is used to transmit binary files over HF. WinLink email is one of the primary users of Pacor. Speeds of 5,000 bits per second are possible with Pacor. What would a waveform of a stream of digital data bits look like on a conventional oscilloscope? A series of sine waves with evenly spaced gaps. B, a series of pulses with varying patterns. C, a running display of alphanumeric characters. Or D, none of the above. This type of signal cannot be seen on a conventional oscilloscope. The answer is B, a series of pulses with varying patterns. What type of information can be conveyed using digital waveforms? A, human speech. B, video signals. C, data. Or D, all of these choices are correct. The answer is D, all of these choices are correct. Dilution of a signal across many frequencies causes spread spectrum signals to appear as wideband noise to a conventional receiver. Spectrum spreading may result in digital signals being below the noise floor of a conventional signal, and thus invisible to it. Another way to spread the spectrum of a signal is via frequency hopping. There, you change the carrier frequency according to a pseudo-random sequence. GPS receivers use spread spectrum techniques to pull the tiny signals out of the noise. While CW, radio teletype, and PSK31 have no inherent error detection or error correction capability, other modes such as packet and Amtor do. Which of these techniques causes a digital signal to appear as wideband noise to a conventional receiver? A. Spread spectrum. B. Independent sideband. C. Regenerative detection. Or D. Exponential addition. The answer is A. Spread spectrum. How does the spread spectrum technique of frequency hopping work? A. If interference is detected by the receiver, it will signal the transmitter to change frequencies. B. If interference is detected by the receiver, it will signal the transmitter to wait until the frequency is clear. C. A pseudo-random binary bit stream is used to shift the phase of the RF carrier very rapidly in a particular sequence. Or D. The frequency of the transmitted signal is changed very rapidly according to a particular sequence, also used by the receiving station. The answer is D. The frequency of the transmitted signal is changed very rapidly according to a particular sequence, also used by the receiving station. How is forward error correction implemented? A. By the receiving station repeating each block of the 3 data characters. B. By transmitting a special algorithm to the receiving station along with the data characters. C. By transmitting extra data that may be used to detect and correct transmission errors. Or D. By varying the frequency shift of the transmitted signal according to a predefined algorithm. Answer C. By transmitting extra data that may be used to detect and correct transmission errors. The next subject is video modes. Hams can and do communicate using television signals. There is slow scan television, which is used on HF, primarily on 14.230 MHz, and fast scan television, which is used on UHF primarily because of its very wide bandwidth requirement. FCC rules prohibit one-way broadcasting, so it is not okay to broadcast live coverage of sporting events. However, in an emergency, transmitting damage assessments to an emergency shelter can be extremely useful. This is what one video line of an RS-170 monochrome waveform looks like. A full NTSC frame would consist of 525 lines such as this. Amateur television is only permitted at or above 420 MHz because of its wide bandwidth requirement. 420 to 435 MHz and 1.2 GHz are the most popular.